So I think that Colin just gave a really great presentation that's an excellent segue into mine, which is Colin talked about how to set goals and how to make sure you meet them. And I'm going to talk about practical ways that you can do that with some software tools to help you sort of manage your project. So, hello, I'm Peter Hajas. I have been in RCOS, I think this is my 4th semester or something like that. And I'm going to talk to you about 2 things today. So the 2 things I'd like to talk to you about today are iOS, which is Apple's mobile operating system, and how you can develop for it, and some things you might not know about it. And then the big part of the talk is Git, which is distributed version control, and we'll talk about what that means later. So first, iOS. My most well-known and easily most successful project for RCOS has been an iOS project called Mobile Notifier. It's an open source notification system for the iPhone, the iPad, the iPod Touch, and kind of the Apple TV, but I don't want notifications on my television, so whatever. It's really successful. It's in its beta stage right now. I've got a good list of about 15 beta testers. I just recently got someone who's dedicated to UI design, so I know what I'm talking about in that respect. I'm also going to be working this semester on a project called Widge, which are widgets for the iOS home screen, something that iOS is severely lacking in. And you'll hear more about these projects at my official project presentation. But as far as developing for iOS, people have this stigma or this idea in their head about what that means. You don't actually need a Mac. You can do all of iOS development and you can build my projects on a computer running Linux, for example. You don't need to use Objective-C. Objective-C is a language that Apple uses primarily. Some people don't like it for certain brackety reasons that I don't understand. And you also, the advantage is you get to write for the best mobile platform that's there.
Is it really the best?
Trust me, it's amazing. So that's iOS development. If you have any questions about how to do it or how to get started, feel free to ask me anytime. I've had the experience of, I only know C++ from Martin Hardwick. How do I approach iOS development and GUI development, stuff like that? It's a daunting task, but I can help you out. So the real thing I wanted to talk to you about today was Git. And Git has something to do with this 8-legged cat sitting in a puddle. But we'll talk about that more later. Git is distributed version control. And we'll talk about what that means a little bit later, but that's sort of the core idea behind Git. Simply put, Git is the best thing you can do for your code. Seriously, the best thing. So, for me to explain why Git is so powerful and why it's such a handy tool, we're going to go back in time. You guys ever seen this movie? We're going to go back in time to, I'd say, about 20 years ago, back when software was still big and people were working in projects. And they had this question: how do we manage source code? We have 4 people working together, usually much more. We need to manage source code effectively. We need to communicate between these teams. How do we do it? Well, the solution they come up with was a patch file. You have this patch file that represents changes, and it tells you how to get from one piece of code, which says hello, to a new piece of code that says hello there. It's more friendly. And how do you get these patch files around? Well, clearly you email them. You email them from developer to developer. People apply the patch. So this was file specific. It only worked on the particular version of the file for which the patch was generated. It didn't work that well for teams because you have to email it to everybody, and oh no, before you emailed that patch, I was working on a different patch. How do we resolve these conflicts? It led to too many emails, which was irritating people. This was a bad idea. So then they developed this piece of software, 2 pieces of software actually, a centralized system. So a repository sitting somewhere on some corporate network, and you can communicate with this repository, and it's centralized, and all the developers can keep their code there, right? 2 common utilities that do this are called CVS, and a rewrite of it called SVN. So let's say we have 3 developers, Steve Jobs, Bill Gates, and Linus Torvalds, and they're all working on a project. So they commit code to the central repository, they check out code, things like that. But all the code lives here. All the code lives centralized. And if there was a conflict, let's say Bill commits something and then Steve commits something that changes what Bill changed, these tools weren't that good at resolving these conflicts. If you haven't caught on by now, this centralized system is absolutely terrible. It's really bad. It only works when you have an internet connection, and not even all the time. It's horrendous for merging and branches and things like that. It's just a really bad design. So there have been some other tools. Let's look at all the tools that are competitors to Git. We've got Subversion, CVS, Perforce, BZR, and HG, which is Mercurial. Now I'm going to take away all the tools that are not distributed, because I'll talk about later why a tool has to be distributed for it to even be something you should look at. So that takes away Subversion, CVS, and Perforce. And now let's take away tools that aren't easy or fast to merge or branch in, like Bazaar and Mercurial. So we can't use any of these tools. It's terrible. So what are we left with? Well, we're left with something in 288-point font, which is Git. Now, what is Git? So let's say we have a project. This is our collection of source files. This is some bizarre project where you're working with like C++, Objective-C, and JavaScript, I guess. But let's just say it's your software project. And you want to initialize a Git repository. So you just run git init, and Git recognizes this as a repository. You can add your files to it, and it'll start to track them. So what does this mean? In a standard project, let's take one of your files, this .m file. Let's say this is a special class in your project that you use all the time, and you're making lots of commits to it. If you were just working regularly, you'd have this one file, the newest version. This is the one, it does the latest and greatest stuff. Let's hope you didn't make a mistake, because you'd have to like undo your mistake. You don't have past versions saved unless you were copying them manually or using Dropbox, which is a terrible idea. Don't do source control in Dropbox. If you were using Git, however, and you were committing well, you have access to every history of this file. You can go back in time. And each of these files has noticeable commit IDs with comments that you left about what you did in each commit. So for you to commit, you'd say git commit -m, you'd give a message, fix the bug where phone would explode, for example. And then it would be committed, it would be stored in history forever, you'd always be able to go back. Now, let's look at another situation. Let's say you had a bug, and you know that this bug is in the most 3 recent versions of this file, but you don't know which one, you don't know how to resolve it. So Git will let you go back in time to the file where it worked by just showing the commit. Git will also, this is more of an advanced command, Git will also do a binary search and help you find where the bug took place. It's awesome, and it does it all for you. Obviously, you have to like sit there at the computer, but it'll help you out with solving bugs, which could take hours and it can take minutes. So let's go back to this example of a project. And let's say I send my project to someone. I send my project to Nate. And I give my project to Nate, and I copy it over. And so now Nate has a copy of my Git repository, let's say. But not only does Nate have a copy of everything that's in the Git repository, Nate and I actually each have every single instance of history since the project was started. Every single change to every file, every commit, every merge, every branch, everything. The thing that Nate has and the thing that I have are totally equivalent. Nate could take this project and run off and do something totally different, and it doesn't touch me at all because he's got his own repository that he uses. It's awesome. This also means that I could get on a plane and continue to work on my repository and not need an internet connection. And when I get back home, if I have a centralized service, I can just push to that centralized service. I haven't missed a beat. I can still work. I can still merge. Let's take the example of a team again. Let's say I'm on a plane and I'm working on software, and Nate's working on the same software online, and he's been committing the whole time. And I get back to my, my house or my humble abode, and I decide to push my code back up to this centralized repository, or not centralized, this other source. Git will allow me to resolve any conflicts that came up. And it's also very intelligent about merging. An important idea behind Git is that Git will never, ever, ever do anything destructive to your files. All the stuff that you throw in, you are guaranteed to get out. None of those other tools promise this. And to be honest, I want all the stuff I put in the box to come out if I wanted it to. So I don't know why you use the other tools. So let's go back to this weird Octocat thing. So what does Octocat have to do with all this? Octocat is the mascot for a service that I and many other RCOS members use called GitHub. GitHub's kind of like a social network like Facebook, but it's for source code, so there are way less girls. But it's still a fun place to be. It's not like sexist or anything. I'm sure that's like a pretty embarrassing breakdown. But it's a really great place to be and to check up on people's projects. So Git stores your source code in the cloud. Now, because Git has a repository, or a copy of your repository in the cloud, GitHub also knows about all your history of your project. For you to send your stuff to the cloud, you just run one command, git push origin. Now, origin is not like some special keyword or something like that. That's just the name that GitHub usually tells you should use for it. So origin is the name of your remote host. I could have a remote host called Nate. I could have a remote host called Tim. I could have as many as I want. And master is the name of the branch that you're pushing. So about branches. Another really powerful capability of Git, I hope this isn't boring or anything like that, is branching. So let's say we're working on our project, we're committing at every step of the way, and that's great, right? But let's say we're right around here, and we want to try to implement a new feature. And usually when you'd implement a new feature, you just implement it and it would work, but you're going to have to change a lot of the source code. You don't know if it's going to work, you don't know if it's going to screw up the project. Let's say, for example, you're writing a very popular game that uses cubes to represent like the world, and you want to somehow like add so that there are different biomes for these cubes, but it might break the game engine, and so you don't want to like undo your changes, and you're like Swedish and really bad at software. So if you're using Git, you can just branch off and make commits in this branch. You do checkout-b, which means make a new branch, and then the name of the feature, or the branch, and then you can continue to work in this branch independently, and you can be switching back and forth between these and working on each one independently, and if at the end you decide this is valuable, I'm glad I did this, you can merge it back in. If you're like, man, this was terrible, why would anyone want to have cake in Minecraft? You just delete the branch and it'll be gone. Now, branching can be done as many times as you want. You can be branching again off of the same master tree, or even you can branch off of a branch and work on an even more experimental feature that you really don't want to pollute the code base. And this all happens like that, immediately. I work on a MacBook Air, which is like the slowest computer in the world, and this happens really, really, really fast. It's essential. So, to conclude, Git is history. It's every version of every file for all your commits dating back to the beginning of time. Git is version control. Lets you keep track of versions, releases, tag releases, all sorts of fun things like that. Git is distributed. Everyone who checks out your project has every piece of history ever, to the beginning of time. Git is easy. With 3 or 4 key commands, you can be working with Git and working really, really well, and it's extremely effective. Git is cheap branching. Finally, you can rethink development and start branching off and trying new features without worrying about destroying source code or needing to undo your changes. Git is adaptive. I have a different way of working with Git than lots of other people do, and Git's okay with that. You can branch as much or as little as you want, and it's great. Git is merging. It's extremely inexpensive and easy to merge. It always resolves conflicts. It always asks you to resolve conflicts. It doesn't try to make any decisions on your behalf that it shouldn't, and it's really intelligent about merging things that don't have conflicts. Git is cross-platform. It works on Windows, Mac, obviously, and Linux. And really, the best way I can put this is that Git is good for you. Git is really, really good for you. So Git is a great tool, right? But how do you use Git right? I think that's like a typo. It's like, how do you use Git correctly or something is what it should be. Basically, there should be 2 policies you should always follow. You should commit often, which means you should store your releases often. And you should push every time you commit. You should send it up to GitHub or any other source. Sorry?
Objection.
Let's hear it, Matt.
Do not push every commit.
Why?
Because sometimes you do horrible, horrible things.
Right, so if you do something terrible that you...
And you will pollute history.
Right. So if you're polluting your history and things like that, which is more advanced features of Git, you might not want to push every commit. I push every commit, and it's awesome. For you to learn Git, I'm not going to talk to you about how to use Git. People have done that to death. There's a really, really killer website for those of you who are on your laptops and not paying attention. You can go to gitimmersion.com. It's a really, really great tool. Walks you through. It's all like Web 2.0. It's kind of fancy. So now let's look at how Git applies to RCOS. How does Git help you do open source? Well, the operative term here is open, right? This should be open development. So Git allows you to keep everyone updated, all of us, on what you're doing. I follow pretty much every RCOS project on Git, and I can see on GitHub, and I can see every time they're committing and what they're doing and what their commit tags are, and it's awesome. It allows really, really easy contribution. When I found a bug in Tim's software over break, he used a font that wasn't included with the system. It was bad. I changed that, and I was able to roll that commit back in. Turns out that I used an even worse font to use, so it was... But it let me do it really easily. It also lets you document your successes. So when something works, you can tag it and show that it works, and then all of us can learn from something that worked for you. And it helps everyone learn. Everyone can learn from your mistakes, too. I didn't want to put the word mistake on this slide, but if you do something that doesn't work out for you, you can show everyone else what didn't work out for you, and then they'll know not to do it too. Everyone improves. Ultimately, the rule you should follow is to show us your stuff. So what does show us your stuff mean? That means every bug fix, every decision, and why you took it. This is essential. Do not wait until everything works before you push up your code or before you commit. Because guess what? We'll never see anything. Your code will never be done. I have news for you. Your project will never, ever be done. So the software is never, never finished. Now, it'll be great, and you'll have releases and things like that, but you're never going to be done. You'll never need to say, oh, you know, when I'm done with it, I'll push it, because it'll never show up. And at that point, you're kind of cheating us, right? We want to see you perform, and we want to see your software. So that's it. I hope I didn't go too fast, but I didn't want to take up too much time. Git is an essential tool. It's invaluable. It helps you write a lot of great software, helps you do it really fast, and it helps you track it really, really effectively. If you have any questions about Git, feel free to ask me. Thank you for letting me present to you. If you think I don't eat my own dog food, you can go to github.com/PeterHajas and see Mobile Notifier back through mid-September, and I don't know, I think I have some references to like Bob Dylan songs back there or something in my commit logs, but feel free to check it out. I do use Git. If you have any questions on Git or how to use it, I'd be more than happy to show you how. I'm going to help some people out after this. Feel free to ask. So that's it. Joe?
Because you have the full repo, does it lead to a longer checkout time initially?
Correct. So for example, there's a really big project on OS 10 called Adium, this little duck guy here. It's a chat program. And Adium's several years old, right? Tim, how old is Adium?
10 years old.
10 years old. To check out Adium, it probably takes 5 minutes. It's huge, right? To check out Mobile Notifier, which is just a couple months old, it takes a quarter of a second. When you have such a big project, it's rewarding that it takes so long. You know what I mean? Because you can see all that history. Git doesn't really let you check out. Does it Git let you check out just like the current commit or no? Do you have to?
I think there is a shallow clone.
But I mean, I know
but you
GitHub
don't
lets
use
you
it.
Get like a
Bad idea.
tarball of the current commit. Are there any other questions? I don't know if I went too fast. You guys all understand why version control is good?
Peter will post your code, your talk slides on the
Of course.
blog.
Yeah, absolutely. You have a
I
question?
had a question about the first topic, iOS. What other languages can you program in Objective-C?
So other than Objective-C, you can write in C, C++, Python, Ruby, Haskell. You can write software in, I think they're Java bindings, but I think they're like 3 years old, so which is like back to the original iPhone.
With the caveat that you cannot then put it in the App Store
Yeah, you
for
can't
some
put
of
it.
these
Well,
languages. For some, the dynamic
for
languages
some
you
things,
can't.
yeah, you have to sign it, but for open source development, it's fine. Yep.
I heard, maybe this is just a rumor, Apple doesn't like runtimes now? There's like a rule against runtimes?
They do now. So they were trying to be averse to it with things like monotouch and Unity and technology like that, but this organization, I don't know if you guys have ever heard of them, called the Federal Trade Commission, got a little bit upset over that. So they changed their policies to be a little bit more lenient. They do like runtimes now, though, and all sorts of App Store apps use like the Flash runtime, and Apple does not like Adobe. Any other questions?
So, I don't have a question, but I just wanted to comment on Peter talking about like, being afraid to push your code. Like, I talked to a bunch of people who like hire programmers, and like, if they see you on GitHub and like see your code, and like can see like crappy code and like how you improved it, it's like infinitely better than them looking for you and seeing no code.
And history speaks volumes, right? To show that you have history with your software and everything.
And by the way, the people outside RPI, inside RPI think a world of RCOS programmers, they think the brain is at RCOS. So your job is to keep up the tradition. So we have a few people who did that, and we have to keep it up. Thanks, Peter.
Oh, thanks a lot, guys. Thank you.